So thank you very much for the invitation. It's I'm very happy to be at UConn again, and look forward to being here many times in the future as well. And I'm attending this lecture for a broad audience, and hopefully with some interesting things to say, even for advanced math majors and people with a similar sense of similar mathematical. So algebraic geometry brings to bear simultaneously ideas from number theory, geometry, and topology. And my intent is to give you some glimpse of how, and I hope at the end to explain some facts at the roots of topology, this notion of Bott periodicity, which can be seen as coming from some simple algebraic geometry. And I want to mainly give you the tools that let us begin to understand these sorts of questions. So before I forget, I'm going to touch on work involving a large number of other people. I just want to make sure I mention their names in public: Melanie Batchelor-Wood, Aaron Landesman, Hannah Larson, Jim Bryan, Paul Shelik, and some more. Between worlds that look quite different. So I'll tell you some beautiful facts that, if you squint and look at them the right way, show some similarities. And these are going to be things about something really very basic that you can see in high school or earlier, which are just about polynomials in one variable. But there are clues to very fancy things here as well. And then I want to give you one tool to make these links, which connects a means of connecting geometry topology by means of algebraic geometry, a way of adding and subtracting and multiplying spaces, the sort of algebra of spaces, which I could give the fancy name of the growth theory of algebraic varieties, and I'll essentially tell you what this is, but really at base it's something really concrete and not, well, I won't say not complicated, but to define it, it's really quite simple, and you can begin to ask some basic things. And then I would end, depending on time, by giving you some sense of where this leads by telling you a bit about the surprise of Bott periodicity and topology, and how it's secretly an algebraic fact. And then maybe, depending on time, how we got there also involves some recent work where part of the advances, it's purely mathematical advances, but they also involved exploring how one does mathematics using new tools in AI, and a recent paper where it feels like we're just playing with how we accelerate mathematical discovery. We're just, in some sense, in human race, we're just starting this adventure, but beginning to see how this works. And maybe one message I'd say is that much of the story in public about it is either dystopian or filled with ridiculous hype, and neither really seems remotely attached to any evidence. And so really, but it is an exciting time, and so we could talk about that as well.